calculating pH. Here we have sodium hydroxide, potassium hydroxide and barium hydroxide. All three of these are considered to be strong bases. When in solution, they break down to give metal ions and hydroxide ions. The reason they're referred to as strong bases is because they fully dissociate. So, for example, if we start with 1.2 molar of sodium hydroxide, we're going to get 1.2 molar of sodium ions and 1.2 molar of hydroxide ions. Molar just means mole per dm cubed. Or if we have 0.08 molar potassium hydroxide, we're going to get the same amount of potassium and hydroxide ions. And let's say we have 0.1 molar barium hydroxide. We're going to get 0.1 molar barium ions and 0.2 molar hydroxide ions. So be careful with this one. Notice that barium hydroxide has 2 hydroxide ions in its formula. Okay, so here we have 100 centimeter cubed of 0.5 molar sodium hydroxide. How would we calculate the pH of this solution? Remember that pH is calculated by doing minus log of the concentration of hydrogen ions. However, sodium hydroxide breaks down into sodium ions and hydroxide ions. So where is the hydrogen ions here? We need to convert this into hydrogen ions. And to do that, we're going to use something called Kw, which stands for the ionic product of water. Now the expression for Kw is the following. Kw is equal to the concentration of hydrogen ions times by the concentration of hydroxide ions. Now we're going to talk about Kw in more detail in a separate video. But for now, we just want to get to the calculation stuff straight away. So we know the expression for Kw. How can we use this now to convert hydroxide ions into hydrogen ions? Well, all we have to do is just rearrange it to look like this. So to work out the concentration of hydrogen ions, all we have to do is work out Kw and the concentration of hydroxide ions. Since we know the concentration of sodium hydroxide is 0.5 molar, and the fact that sodium hydroxide and hydroxide ions have a 1:1 ratio, that means the concentration of hydroxide is also going to be 0.5. As for Kw, the value is 1 times 10 to the power of minus 14. So make sure you remember this number. Now I have to mention that this is temperature dependent. So at 25 degrees Celsius, the value for Kw is 1 times 10 to the minus 14. However, if the temperature is not 25 degrees, then it will be a different value. In this scenario, in the question, they'll probably tell you what the value is. So just remember, Kw is 10 to the minus 14 unless specified differently in the question. Okay, so now we can work out the concentration of hydrogen ions. And that's going to be 2 times 10 to the minus 14. Excellent. So now that we have that, we can work out pH by doing minus log of the concentration of hydrogen ions, and that will equal to 13.69. And this makes sense, considering we have a strong base, so it should have a high pH. Here's a different question. We have 150 centimeter cubed sodium hydroxide solution. We've been given the pH, it's 12.8. However, we want to work out the concentration of sodium hydroxide in the solution. So what we need to do is work out how we can go from pH to sodium hydroxide. We know that from pH, we can work out the concentration of hydrogen ions by doing 10 to the power of minus pH. Once we have the concentration of hydrogen ions, we can then convert this into hydroxide ions using Kw. And then we can simply do the ratio of hydroxide to sodium hydroxide and work out the concentration of sodium hydroxide. So pH is 12.9. 10 to the power of minus 12.9 will give us 1.26 times 10 to the minus 13. So now that we have the concentration of hydrogen ions, how do we convert this into hydroxide ions? Remember, Kw is equal to H plus times OH minus. So we're going to rearrange it so that we get OH minus equals Kw over H plus. Remember that we said the value for Kw is 10 to the minus 14 unless specified differently in the question. So we're going to use 10 to the minus 14 because they haven't told us in the question that it's a different value. Then, the concentration of hydrogen ions is 1.26 times 10 to the minus 13. This gives us 0.079. Okay, the final step is to use this to work out the concentration of sodium hydroxide. We know that the ratio is 1 to 1, so therefore the concentration of sodium hydroxide will also be 0.079. And that's the answer. So as long as we have this chain of events, pH, H+, OH-, and then your base, you can always work out questions like this. A quick side note. Let's say we were dealing with another base, such as barium hydroxide. And let's say we worked out that the concentration of hydroxide ions was 0.08. To work out the concentration of barium hydroxide, you'd have to divide it by 2 in this case, since the ratio is 1 to 2. So make sure you don't make this mistake in an exam. Okay, moving on to a different calculation. Let's say we mix hydrochloric acid and sodium hydroxide. Now we know how to calculate the pH of a strong acid on its own. And we just learned how to calculate the pH of a strong base on its own. But what about the pH of the solution formed when these two mix together? We know it's a neutralization reaction, but will the pH always be 7? Let's find out. So the first thing we're going to do is work out how many moles of H+ we have on the left and how many moles of OH- we have from the right. Remember that H+ comes from hydrochloric acid and OH- will be coming from the sodium hydroxide. Starting with the left, we can use the equation that moles is equal to concentration times volume over 1000. With this, we can work out the moles of hydrochloric acid. So we have the concentration, which is 0.3, and the volume is 50 centimeters cubed, which is why we're dividing it by 1000. That gives us 0.015 moles. We know the ratio of hydrochloric acid to hydrogen ions is 1 to 1. Therefore, the moles of H+ is also going to be 0.015. Moving towards the right, we're going to use the same method to work out the moles of sodium hydroxide. And that gives us 0.014. And again, the ratio is 1 to 1, therefore the moles of hydroxide will also be 0.014. Okay, now both of these ions are moving into the solution and reacting with each other. In step 2, we want to work out, do we have any excess ion left, and if we do, how much? So we can tell from our moles that there are more hydrogen ions present than hydroxide ions. So that means we're going to have excess 0.001 moles of hydrogen ions left after these two react. And the way we get that is simply by doing hydrogen ions take away hydroxide ions. In step 3, we want to work out the concentration of this excess hydrogen ions. To do that, we're going to use the equation moles is equal to concentration times volume over 1000, but we're going to rearrange it such that we can get concentration. So the concentration of the hydrogen ions is going to be 1000 times 0.001 divided by 90. The reason we got 90 is because we add the volume of the two solutions that are mixing together. So 50 on the left and 40 on the right come together, so our new solution is going to have 90 centimeters cubed. And that gives us a concentration of 0.01 recurring. Step 4. Now that we have the concentration of hydrogen ions, all we have to do to work out the pH is do minus log of the concentration of hydrogen ions. And that's going to equal to 1.95, which is the pH of the solution in the middle. So we learnt here that just because you have an acid and a strong base, you're not always going to get a pH of 7. And that is because obviously they're not in equal amounts. Also notice that we had excess strong acid. Because of that, the pH is low. 1.95 is relatively acidic. However, what would happen if we had excess strong base, and how would the calculation differ? Let's find out now. So this time, we're using the same amount of hydrochloric acid with the same concentration. As for sodium hydroxide, we've doubled the volume to 80 centimeters cubed. So let's find out what the pH of this mixture is going to be. Again, step 1, we're going to work out the moles of H plus and OH-, which are coming from the hydrochloric acid and the sodium hydroxide respectively. So starting with the left, the moles of hydrochloric acid will still be the same, 0.015, so we have 0.015 moles of H+. As for the right side, the moles of sodium hydroxide is going to be 0.028, and so will the moles of hydroxide ions. Step 2, let's work out which one will be in excess. So we can tell here that the excess is going to be the hydroxide ions, and we can tell here that we're going to have 0.013 moles of hydroxide remaining after the reaction has finished. In step 3, we now have to calculate the concentration of the excess ion. So again, we're going to use this equation and rearrange it. And that's going to give us 1000 times 0.013, which is the excess moles of hydroxide ions, divided by the total volume, which is 50 plus 80 added together, 130. And the concentration is going to be 0.1. Now remember that we can't work out pH using hydroxide ions. We have to convert this into hydrogen ions. We're going to do that by using Kw. So we're going to rearrange it, and we get the following. H plus is equal to Kw divided by OH minus. Remember that Kw is 10 to the minus 14 unless specified. And OH minus is 0.1. So the concentration of H plus is going to be 10 to the minus 13. And now in step 4, we can work out the pH by doing minus log of H plus. And that's going to equal to 13. So again, the pH of the mixture is high this time because we had excess strong base. So in this video, we learned how to calculate the pH of a strong base and also how to work out the pH of a mixture of strong base and strong acid. Hey guys, if that video helped you, support our channel by liking, subscribing and sharing it with your friends. And more importantly, if you still have questions, drop a post on our forum at ExamQA.com, where I will personally be there to help answer your questions. Mohammed signing out.